Today we are talking about an interesting vegetable, mushroom. When you are cooking vegetables such as potato, zucchini, if you step out to take a call, you might find the vegetables are too soft. When you are cooking meat, if you get distracted, you could end up with a plastic brick. But mushrooms are much more different. Even if you're away from a pan for 9 hours, when you come back, the mushrooms are likely to still be glossy and tender. Why? Few years ago, an experiment was set out to confirm this phenomenon and spent 40 minutes steaming half-inch thick mushroom, zucchini, and beef tenderloin. Every 5 minutes, a machine measured how much force would be required to bite 3 millimeters into each one. Also give them to human testers to try. Then the results were recorded. After 5 minutes of steaming, the zucchini, beef, and mushroom were all equally tender, requiring about the same force for a bite. The mushrooms stayed the same for almost the whole 40 minutes, getting only 57% tougher in total, and still seemed tender to the tasters. In deep contrast, the beef was 3 times more tough after the same period of cooking. Meanwhile, the zucchini decreased 83% in firmness, turning into vegetable mush. So, what gives? The answer, it turns out, is chitin. It's found in lobster and shrimp shells and insect wings. It mostly serves to protect soft tissue in the natural world. Chitin is remarkably resistant to heat. In 2015, a study found that fungal cells with chitin walls could withstand temperatures up to 308 degrees Celsius. Other cellulose samples dissolved around 300 degrees Celsius. This remarkable strength is from chitin and its structure. In mushrooms, chitin takes the form of fine bundles, each of which is made up sheaths that are layered in parallel but run in opposite directions. Those sheaths are held together by strong hydrogen bonds, making them even more durable. All that is quite different from the molecular making up of meat and vegetables. When the protein in meat are raw, they are soft and flexible, but as they heat up, they contract together, pushing out moisture. The empty space causes the proteins to contract even further, eventually drying the meat out and turning it hard and tough. In vegetables, on the other hand, the hemicellulose and pectin that hold plant cell walls together begin to break down after exposure to heat, releasing the bond between those cells at much lower temperatures than chitin does. That's why mushrooms are so amazing. You cannot overcook them. Mushroom, great.